Hello everyone, I'm Namin Nan, a second-year PhD student at KAIST AI. In this video, I will present a work that was recently accepted to ACL 2025. In this work, we revisited the widely used contrastive language image pre-training, the CLIP model, which is known to perform well in many zero-shot multi-model tasks. However, despite their success, CLIP and its variants also suffer from a significant limitation known as the modality gap, which is caused by image and text embeddings projected to separate manifolds in the latent space. While the root cause of this phenomenon has been debated, whether it is because of the data type, high model dimension, or learning objective, there is no consensus on which of these causes is the most relevant. This undesirable symptom of modality gap is emphasized when we apply the model as a metric, resulting in CLIP score models. As you can see in this right example, while CLIP score assigns an unintuitive lower score for the correct image-text pair compared to the irrelevant pairs within the same modality, our proposed I0T score could largely improve the scoring system. During our preliminary analysis, we first categorized the modality gap into different severity levels, low, moderate, and high, based on the relationship between linear separability, minimum cosine distance, and centroid distance, which are widely used definitions for defining the modality gap. We find that these three different definitions could be integrated into one categorical definition based on the piecewise linear function properties such as linear separability plunging when the minimum cosine distance is below 0.2. Another interesting phenomenon we observed is that the pre-trained CLIP consistently shows positive and negative peak activations at a few dimensions in text and image embeddings, causing the modality gap. Thus, in order to build a model that reduces the modality gap, in the first stage, we fine-tune CLIP model using long CLIP model architecture, long captions only from the shared GPT-4v dataset, and cyclic losses, which overall improve the downstream performance compared to CLIP. Then, in the second stage, we apply post-hoc and learnable methods with the objective of reducing the modality gap. To be specific, we standardize the normalized embedding activations of image and text embeddings separately across all the test samples for the post-hoc method, and we simulate this process by applying separate batch normalization in layers in our learnable method, which builds I0T async. We find that our final I0T async, which uses asynchronous training strategy, performs better than the non-asynchronous ones, and a models trained with additional layer normalization layers in terms of both downstream performance and modality gap. Overall, our post-hoc and trainable methods rank top 1 and top 2 respectively in terms of the average modality gap and downstream performances of image text retrieval, image classification, and image text correlation with human judgments, which outperform all these state-of-the-art methods. Not only that, we find that I0Ts, which show higher performance than a non-CLIP-based model called BLIP, and the highest performance using more test samples, can be directly applied as an automatic evaluation metric, outperforming CLIP score and PAC score. Although there could be a trade-off between modality gap and downstream performance, we claim that there is no direct causal relationship between the two, and using our method significantly reduces the gap while preserving the performance. The effectiveness of our proposed separate batch normalization approach removes the aggregated mean and standard deviation statistics of the normalized embedding activations, which effectively removes the constantly similar values of means and minuscule standard deviation observed across data samples per modality. Future works could possibly delve into different learning methods and additional modalities such as video and audio. Thank you for listening. If you have any further questions, please email me or read our paper for more details. See you in Vienna.